Hello, 5th grade math students. This is Chapter 7.6, More Real-World Problems with Ratio. We'll learn several different techniques for solving word problems that involve ratios. Let's begin. The first technique we'll learn is to use simplest form ratios to compare quantities. At a toy shop, Bernice bought 3 pink toy cars, 6 blue toy cars, and 9 yellow toy cars. What is the ratio of the number of pink toy cars to the number of blue toy cars to the number of yellow toy cars that Bernice bought? There are 2 different ways that we can solve this problem. Method 1 involves visualizing placing our cars into boxes by the greatest common factor. Because our greatest common factor is 3, we'll place 3 cars into each box or group. So we have 1 group of pink cars, 2 groups of blue cars, and 3 groups of yellow cars, making our ratio 1 to 2 to 3. So Bernice purchased a ratio of cars, 1 pink, 2 blue, 3 yellow. Let's look at method 2. In method 2, we'll begin by writing our 3-part ratio, 3 to 6 to 9, and then using the greatest common factor to reduce it to its simplest form. Since 3 is our greatest common factor, we'll divide each term by 3, giving us our new ratio of 3 divided by 3 is 1, 6 divided by 3 is 2, and 9 divided by 3 is 3. So the ratio of the number of pink toy cars to the number of blue toy cars to the number of yellow toy cars is 1 to 2 to 3. Okay, let's try this on a problem of your own. Here's practice problem number 1. During a track event, Darren ran 200 meters, Shelby ran 800 meters, and Antonio ran 3,000 meters. What was the ratio of the distance Darren ran to the distance Shelby ran to the distance Antonio ran in simplest form? You may use either method 1 or method 2, whichever works best for your brain. Press pause while you work, and we'll move on to our next problem-solving technique when you're finished. Now let's explore using equivalent ratios or models to solve word problems. Rebecca filled 3 containers, A, B, and C, completely with orange juice. The containers' capacities were in the ratio of 2 to 3 to 4, as you can see from the bar model I've drawn here. The capacity of the largest container was 12 cups. Find the capacity of the smallest container. Okay, so there are 2 possible methods that we can use for this. One is to use the bar model, as we've learned to use in previous chapters. What we know here is that we have 4 units, 1, 2, 3, 4, equaling 12 cups. Therefore, we can find the value of 1 unit by dividing each side by 4, which I'm going to show in fraction form. So 4 divided by 4 gives us 1 unit, and 12 divided by 4 gives us 3 cups. So we know that each individual unit is 3 cups. Therefore, we know that B is valued at 9 cups, and A is valued at 6 cups. So the smallest container has a capacity of 6 cups. Okay, let's look at method 2. In method 2, we'll simply use equivalent ratios to find the value. We know that the ratio of A to B to C is 2 to 3 to 4. We know that the value of C is 12 cups. So we can write an equivalent ratio where the value of the third term is 12. Now we need to look for a multiplying factor. What will we multiply 4 by to get 12? Or what is 12 divided by 4? It's 3. So to find the value of A and B, we'll multiply those terms by 3. 2 times 3 is 6. 3 times 3 is 9. Therefore, the capacity of the smallest container is 6 cups. Once again, you can use either technique, whichever one works best for your brain. If you like to visualize it by drawing the picture and using the bar model, go for it. If you like to use method 2, which uses the equivalent ratios, you may do that as well. I personally like method 2 better. I think it's faster and easier for my brain. Okay, let's go on to a practice problem. Here's practice problem number 2. Raymond cut a roll of ribbon into 3 pieces, X, Y, and Z, in a ratio of 4:2:1. The length of the longest piece of ribbon is 28 centimeters. Find the total length of the 3 pieces of ribbon. Okay, I've helped you out here by drawing a bar model for you that you can use to solve using method 1, or here's your ratio if you'd like to use method 2 or the equivalent ratio technique. Use whichever one works best for you. They'll have one more practice problem using these techniques following problem 2. So press pause while you work, and when you're ready, move on to number 3 on the next screen. And here's practice problem number 3. The amounts of Mrs. Cato's monthly car payment, electric bill, and grocery bill last month were in the ratio of 5:4:6. The grocery bill was $432. How much was the total amount of these 3 bills? Once again, I've given you the information you need to use method 1, which is the bar model here. So if you'd like to solve using the bar model, here you go. And for method 2, here's your ratio so you can find your equivalent ratio if you'd like to solve using that technique. Press pause while you work, and when you come back, we're going to work with solving fraction form ratios. Now let's learn to draw models to solve problems that involve ratios in fraction form. Camille's salary is 2/5 times Ben's. So first, let's find the ratio of Ben's salary to Camille's salary. Well, if Camille's salary is 2/5 times Ben's, then Ben's salary will be the opposite, 5/2, or 5/2, or 2.5 times. So the ratio of Ben's salary to Camille's salary is 5/2. Next, if Ben earns $895, how much did Ben and Camille earn together? So what is C plus B? Well, here we'll want to draw a model. Ben's salary is equal to 5 units, and Camille's salary is equal to 2. So how many units do we have altogether? We have 7. Okay? So using our model, we can solve that Ben's salary, being $895, is equal to 5 units. So we can find the value of 1 unit by dividing each side by 5. Which will give us 1 unit being equal to $179. Okay? So if we want to know the full value of all 7 units, we'll take 7 times $179 to give us the value of 7 units, which equals, sorry, I ran out of room at the bottom here, so I'll put it off to the side, which equals $1,253. So Camille and Ben together earned $1,253. Let's work through practice problem number 4. The number of coins Layla has is 7/3 the number Sally has. There are 2 parts to this question. Part A asks you, what is the ratio of Sally's coins to Layla's coins if Layla's coins to Sally's coins is 7/3, or 7/3? Okay. The next part, part B, says Layla has 896 coins. How many coins do the 2 girls have together? The easiest thing to do here will be to draw a bar model where you set the number of units of coins Layla has, 7, as equal to 896, and then solve for the total number of coins from there. Press pause while you work. Don't worry if you get stuck. We'll do these together tomorrow as well. For our final technique in this chapter, we're going to use models to solve multi-step word problems. So Carla's savings is 4 times as much as Paolo's. Question A asks us to find what is the ratio of Carla's savings to Paolo's savings to their total savings. So we want to know what's the ratio of Carla to Paolo to total. Well, Carla's savings is 4 times as much, so her amount will be 4. Paolo's will be 1. So the total amount will be Carla plus Paolo, which is 4 plus 1 equals 5. So the ratio of Carla's savings to Paolo's savings to their total savings is 4 to 1 to 5. Part B asks us how many times their total savings is Carla's savings. Well, the ratio of Carla's savings to their total savings would be 4 to 5. However, we need to pay attention to how this question is being asked. It doesn't say what's the ratio. It says how many times their total savings is Carla's savings. That means we need to write it in fraction form. So Carla's savings is 4 to the total is 4 to 5. So we would convert that to fraction form by taking the first term and making it our numerator, drawing a fraction bar, taking our second term and making it the denominator. So Carla's savings is 4/5 times their total savings. Question C asks us how many times Carla's savings is Paolo's savings. We'll begin by writing the ratio of Paolo's savings to Carla's savings. That would be 1 to 4. And once again, since it's asking us how many times Carla's savings is Paolo's savings, we need to change that to its fraction form, which would be 1 over 4. Finally, question D asks, they save a total of $120. How much does Carla save? Well, if our total units, 5 units, I'm going to work this up over here where we have a little bit more room. We know that our total is 5 units, and that's going to be equal to $120. So to find the value of 1 unit, we need to divide each side by 5. I'm going to do that showing the fraction form. So 1 unit is equal to, what's 120 divided by 5? It is $24. So 1 unit is valued at $24. The question asks us, how much does Carla save? Well, Carla saved 4 of our units. So 4 units is going to be equal to 4 times $24. Or Carla's savings is equal to $96. Okay? The other method you could use to solve looks like this. We know that the ratio of Carla's savings to their total savings is 4/5. We solve for that in part B. So we can take 4/5 of, remember of is code for times, $120 to solve for Carla's savings. You know how to multiply fractions. We can do this. Let's begin by cross-reducing. Remember that 120 is over 1. So 5 does go into 120 equally, so we're going to divide 5 by 5, and we're going to divide 120 by 5, giving us new fractions of 4 over 1 times $24 over 1. We can just ignore the over 1s from now on. So 4 times 24 equals $96, meaning that Carla's savings was $96. You can use either one of those 2 techniques to solve for the type of problem that we just completed. All right, let's move on to the last practice problem for Chapter 7.6. All right, let me walk you through this fairly complicated problem with lots of parts. In a swim and run biathlon, Raoul ran 5 times the distance that he swam. Question A asks, what is the ratio of the distance he ran to the distance he swam to the total distance of the biathlon? That one's pretty straightforward. Part B asks, how many times the total distance is the distance he ran? Again, be careful here because it's asking you how many times the total, so you want to make sure your answer is in fraction form. And then finally, part C asks, Raoul ran 3,200 feet more than he swam. What was the total biathlon distance? Okay, this is a little bit tricky because it's not telling you that he ran 3,200 feet or that he swam 3,200 feet. It's saying that he ran 3,200 feet more than he swam. So when you draw your bar model, you want to make sure that you are indicating that the difference between the distance swam and the distance ran is equal to 3,200 meters. Okay? So make sure you're really careful about what number of units you make that 3,200 feet equal to. We'll go over this problem together tomorrow. Good luck. Not that you need it because you have skill on your side. I'll see you tomorrow to work through more of these word problems together. Have a great night.